Today's video is on integration using residues. In today's video, we are going to solve a problem using residue theorem. So in this video, we have to evaluate integral e power 2z by z plus 1 whole cube into dz using residue theorem, where c is mod z is equal to 2. So here it is integral f of z into dz. So clearly our f of z value is given as e power 2z by this is z plus 1 whole cube. So in order to find the residues, what we have to do? So we have to equate the denominator to 0. So after equating the denominator to 0, so that is z plus 1 whole cube to 0. So we got z is equal to minus 1 is a pole of order 2. Is a pole of, this is order 3. See here, the pole of order 3. And therefore, what is the circle given here? The circle is given as mod z is equal to 2. Clearly, if you see mod z is equal to 2, this will be mod z minus 2 is equal to 2. And it is a circle with center 0 and radius 2. So it is a circle. So minus z, we have to check the pole which lies within or on the circle. So first of all, so this is 0, this is 1, this is minus 1. So this is plus I and this is minus I. And this will be, so this will be minus 2I. So this is minus, this is plus 2I minus 2I. So this value is 2 and this value is minus 2. So we have to draw a circle with center 0 and radius 2. So here I have drawn this one. So this is a circle where 0 is the center and 2 as radius. So among these 2, minus 2, minus 2I and plus 2I, z is equal to minus 1 is here, this one. So this lies inside the circle. So if it lies inside the circle, so we have to move with finding the residue. So now we have to find the residue for this. For finding the residue, see residue of f of z at point z is equal to z naught of order 3 is nothing but 1 by m minus 1 factorial into, this is limit z tends to z naught, this is d by dz power m minus 1 into, this is z minus z naught power m into f of z. Clear? Here m value is nothing but the power value. So what is our power? So the order value here is 3 and z naught value here is minus 1. Pole value is minus 1 and the order value here is 3. And f of z value is also very clear, that is e power 2z by z plus 1 whole cube. Now if I substitute here, this will be residue value. The residue value at point z is equal to minus 1 is residue of f of z at point z is equal to minus 1 is 1 by, this is 3 minus 1 factorial into limit z tends to, this is minus 1, d by dz value, this is 3 minus 1 and this is again 3 minus 1 and z minus, so here it is minus 1, so this will be minus of minus plus 1 and m value here is 3 and f of z value is this one, that is e power 2z by this value is z plus 1 whole cube. So if I cancel this one and substitute z is equal to minus 1, so before that one, we have to make a derivative, that is limit. So this is 1 by 2 factorial, limit z tends to minus 1. This is d by dz square into e power, this value is 2z. So we have to make a derivative for 2 times. For the first time, this one value will be, so limit z tends to minus 1, the first derivative value will be 2 into e power 2z. And next derivative will be 1 by 2 factorial into limit z tends to minus 1. So this will be 2 2s of 4 into e power, this value is 2z. And again we have to substitute z is equal to minus 1. This is 1 by 2, 4 times e power minus 2. So if I cancel into, this is 2 into, so this value is 2 into e power minus 2. So this is a residue value for the corresponding pole value z is equal to minus 1. See, we got the pole value. For pole value z is equal to minus 1, residue of f of z at pole value z is equal to minus 1, we got as 2 into e to the power of minus 2. Now we have to use the residue theorem. So how we have to use the residue theorem? By residue theorem, by residue theorem, this is integral f of z into dz is nothing but this is 2 pi I into sum of the residues at interior poles. So this is integral f of z dz is nothing but 2 pi I into sum of the residues, that is 2 into e power minus 2. So this will be 4 pi I into e power minus 2, or else this is 4 pi I by this value is e square. So this is f of z is nothing but e power 2z by this is z plus 1 whole cube into dz value. So this is our required value, that is 4 pi I by e square. So let me explain you once again. So this is the question asked. We have to evaluate integral f of z dz using the residue theorem, where c is mod z is equal to 2. So f of z is given like this. So in order to find the poles, we have to equate the denominator to 0. That is z plus 1 whole cube is equal to 0. So z is equal to minus 1 is a pole. So z is equal to minus 1 is a pole, and the circle given here is mod z is equal to 2. So this can be written as mod z minus 0 is equal to 2. So this is a circle with center 0 and radius 2, and therefore z is equal to minus 1 is within the circle. So we have to find the residue for this corresponding pole. For finding the residue of order 3, residue of f of z at z is equal to z naught is nothing but 1 by m minus 1 factorial into limit z tends to z naught d by dz power m minus 1 into z minus z naught power m into f of z. Here m is the order value 3 and z naught is the pole value minus 1, and f of z is this one, and after substituting everything here, we got the pole value as 2 into e to the power of minus 2. So according to our residue theorem, so integral f of z dz is nothing but 2 pi I into sum of the residues of the interior poles, that is 2 pi I into 2 into e power minus 2. The value here is 2 pi I by e square. So this is how we have to solve. This is also very, very important. Please practice and score more in your examinations and pass it on to your friends, and thank you for staying till the end.